Hi students, this is exercise 1.1, question number 1. Find the inverse if exists for the following matrix. So let us take, let A is equal to the matrix minus 2, 4, 1, minus 3. So we are asked to calculate the inverse of the matrix. So you know A inverse is equal to 1 by determinant of A into adjoint of A. So to find A inverse, we have to calculate the determinant of A. So determinant of A is equal to determinant of minus 2, 4, 1, minus 3, which is equal to minus 2 into minus 3, 6, minus 4 is equal to 2, not equal to 0. So we have seen that the determinant is not equal to 0. We know that for any given matrix, if the determinant is equal to 0, we call the given matrix is a singular matrix. In this case, A inverse does not exist. Only if, for example, some A is equal to 1, 2, 3, 4, then determinant of A is equal to 4 minus 6 is equal to minus 2 not equal to 0, then only we say the given matrix is a non-singular matrix. It is a non-singular matrix. If it is a non-singular matrix, then A inverse exists. So now the question is, find whether the given matrix is singular or non-singular. So we have shown that the given matrix is a non-singular matrix. It is a must. We have to mention that A is non-singular matrix. If it is a non-singular matrix, then we go for finding A inverse. Then A inverse exists. So if A inverse exists, A inverse is equal to 1 by determinant of A into adjoint of A, we have written here. So to find adjoint of A, we have seen the shortcut method. Adjoint, interchange the diagonal elements. So minus 3, minus 2. The non-diagonal elements, change the sign of the non-diagonal elements. This is adjoint of A. Now therefore, A inverse is equal to 1 by determinant of A, which is nothing but 2, into adjoint of A, where we have got the adjoint of A as minus 3, minus 4, minus 1, minus 2. So A inverse, find whether it is singular or non-singular. If it is a non-singular matrix, then A inverse exists.